where you are, or you can know where you are on the map. So you can see as I'm moving my mouse, so the coordinate is changing. Also, you have the scale which you can use to zoom in or zoom out or to enlarge the view of the map. And you have the like a zoom percentage and some other, and this is very important, like the coordinate reference system, so of your map project. So I will begin by illustrating how to install the Quick Map Services plugin, which will be used to add base map to QGIS. So just to mention, like QGIS is a very powerful and popular GIS software, which is like open source and free. So there are a lot of people that are contributing to QGIS, and it has a lot of plugins. Like people are contributing or building very useful plugin that you can easily integrate to QGIS for your purpose. So Quick Map Services is one of these plugins, and it's a very popular plugin that is being used to add several base map layer, like the OpenStreetMap, the Google base map, and the like. So to install a plugin in QGIS, the straightforward approach is you come to the menu bar. So these are the menu. So you click on plugins. So you go to manage and install plugins. So the first option, you click on it. So the plugin interface here will open. Sorry, let me close this Grammarly. So the plugin interface will open. There are a lot of plugins. You can see almost 2,000 here. So you can search for the particular plugin that you want to use. So in this case, you want to install the Quick Map Services plugin. So as you saw it in the PDF file, so you can copy the name here and just search. You paste it there to search for the plugin. So you can see it listed in the search results. Then because I've already installed it, so it will ask me to either uninstall or reinstall it. But in your case, you are going to see like install plugin here. Maybe I should uninstall it just to show you how to install it. So now that I've removed it, so I want to install it again. So you can see install plugin. Then you click on it. It will take a few seconds to complete. So that's all to install the Quick Map Services. So you can close this. Then that's the first part to install the Quick Map Services. So the second part is to go to web in the menu bar. So now you see the plugin that you just installed. So if you haven't installed it, the Quick Map Services, so it will not appear under this web menu. Also, if you are installing it for the first time, so you wouldn't see all these base map products listed here. These are listed because I've installed Quick Map Service before and I've done all the settings. So in your case, you wouldn't have like all these options, but to enable all these base map products, so what you need to do is to come to settings here. So you can expand this interface. Then you come to more services and you click on get contributed pack. Then okay. Then you can save. So if you come back to web here in the menu bar and you click on Quick Map Services, so you're going to see a lot of base map products. just to show us what they look like. So I will use like the OpenStreetMap base map. So you click on OSM. So I will use the standard base map, OSM standard. So this is what a typical base map look like, just an image of the whole globe. So you can zoom into any place that you want to go to, but I'll remove it for now. We are going to add it later. So the other plugin, like the OVO toolbox, I wouldn't want to remove it because of time, but I'll just show you like how you will install it. So we are done with the quick map services. So the next one is the OVO toolbox. So you can also copy the name from the PDF file. Then you come back to QGIS. So again, you go to the menu here. These are the menu. Plugins. Manage and install plugins. So this time around, you search for OVO toolbox. So you just paste it here. But because of the space I put in between them, so it will not appear because the spelling doesn't match exactly. So you have to remove the space between OVO and toolbox. So you see the plugin. So you just have to, like the first time you want to install, so you'll see like install plugin here. So which you have to install. So after the installation, close. So the OTB will appear in your processing toolbox. So in case you don't have your toolbox appearing on your map interface, like I have my here. So I will close this one so as to show you how to bring out your toolbox. So to enable your toolbox like to display here, so you go to the menu bar again. So you go to processing and you see toolbox. So after you have installed the OTB plugin from the plugin menu, so once you come here, you're going to see the OTB listed here. But you might not see all this option. So that is where the file that I showed you earlier. So this file that we downloaded. So that is where it is important. So you have to go to the location where this was saved on your laptop. Then you have to unzip it. And I'll show you how to connect it to QGIS. So you come here in the processing toolbox. Let me expand it a bit. So this last icon, options, so you click on it. So you come to providers. Then you see the list of some plugin. So under OTB, just expand it. So you have to set two important folder or path in this OTB. So the first one you have to set is the OTB folder. So this particular file that you downloaded, so you have to locate where it is on your folder and unzip or extract the folder inside it. So you set the folder, which I've already done in my case, so but I will also show you like how to connect to the folder. So you click anywhere in this blue space, you double click, then these three dots will appear. So you click on it. So it will open your browser or your file explorer. Then you go to where you have that OTB, like this particular file that you downloaded here, where you save it on your file explorer or folder. So in my case, and also if you download the full file I shared that was shared with you, so you can see the folder here, OTB. So this version might be different, but I've been using this version for a long time, so I don't want to change it. And it's working well. So you select this main folder. Then you select, so this OTB folder. So you select the main folder. But for this second part, the application folder, So you have to trace this file path. So you open the main OTB folder, you go to LIB subfolder, then you go to OTB subfolder, and you now find this application folder. So let me show that. So I will remove this one, which is the current path of folder. Then I will add it again to show you. So you come to OTB folder, the main folder, you double click to open it. So you come to LIB subfolder, then OTB subfolder, and you select application folder. Then you select folder. Okay, and that's all. So it will take a few seconds or a few minutes to load. Yeah, so that's how to install the two plugins that we need for this purpose. Sorry, can I proceed to the main task?
Some people have questions like, maybe
Okay, let me
let's
see. I'm
briefly
trying to
go to
find the
the
chat.
chat box to respond to them. Please, can you share the link to download the OTB tool in our PC?
Okay,
And
this link. But like if you just I will send the link, but just to if you open this particular file, like this PDF file, everything is there, like where you have to download the QGIS, where you need to download the OTB, but I'll copy the link and paste it in the
someone said I installed Ophio Toolbox Strip plugin, but I couldn't find it in the processing toolbox. What could be the reason? And for the people asking where is the link, just go up the chat. We pasted the link there. So just click on the link we provided and you'll be able to see it. Go up the chat.
for the person that asked about like he or she installed the OTB but couldn't find it in the toolbox. Actually, I can't say what went wrong unless maybe I saw the your screen, which is not like visible now because of time. Where is the link? So I'll just reply to a few messages, then I proceed. So because of time, I wouldn't like go back to explaining the progress of installing OTB or quick map services. So what I did now has been recorded. So later, if you want to go back to do it on your own, so you can easily watch the recording. And also like here, I put like short tutorial that can guide you on how to install this plugin. So anytime you can go back to this file on your own, and that's why we made the files and the data available so that you can do it on your own. So without much Yeah, so without taking much time again, so I'll proceed and start the proper practical task. So if you download the folder or the file shared with you, so you have almost the same list of folder and file like I have. So you might not have this PowerPoint, but you have the PDF version. So I prepared this PDF apart from guiding you how to install the software and getting familiar with them. So I prepare like part of it to guide us through the step that we're going to take for today's class. So in the folder, you have data. So inside the data folder, you have the boundary data. So which is like a polygon that define the extent that we want to analyze for this particular land cover task. So the second one is satellite image. Let me open. So start image folder. So let me go back to the boundary folder, sorry. So you have a shape file of Adijia local government, which is a local government in northern part of Nigeria. So in the second folder, inside data folder, you have satellite image or start image folder. So it contains the satellite images that we're going to use. So this composite band is empty, but we're going to generate like a result and put inside the folder in QGIS. But here you have the single band. So remember, yesterday we looked at blue band, green band, red band, and the like. So these are images acquired for each of these bands. So also yesterday we looked at viewing or visualizing images in multispectral or band composites by looking at image in blue, green, and red or RGB. So this is an example of a single image that is composed of more than one band. So we are going to look at how we can combine this single band image into multi-band image. So in the train file sample, so these are the sample that we need to use to train our machine learning algorithm. Like I showed yesterday, you have some sample, you give the computer to learn from them, then it uses that learning or knowledge that it learns to classify the whole image. So we're going to use this sample to do that. Then, so that's all about the data. So in the other folder, you have the maps. We're going to generate like a land cover map, which we're going to put inside this folder. So you have the OTB folder, which I've showed you how to connect to QGIS. So this output, we are going to generate some output during the process. So we are going to have like a raster land cover layer, which is going to be put here. We are going to also have what they call error matrix or confusion matrix. Also, when you give the algorithm or the computer model, when you give it some sample and the image to learn from, so you can save the model that has learned from the sample and the image, and this model can now be used to classify the whole image. So I'm going to explain further during the practical aspect. And these are layer or style to make it easy for us to apply symbology to the layer in QGIS. So you can save some layer, some symbology or style, so that instead of repeating a process of changing symbology or how a particular layer will appear, so you can easily appear a symbology file. And lastly, you have the PDF I'm showing here. So these are a few sources of where we got the data, which you can check later on your own. So maybe to just give a brief overview of like the study area we are going to use for this particular task. So it's in Nigeria, in northern part of Nigeria. So you can see the map of Africa, and Nigeria is here. Then this particular study area is northern part of Nigeria and is within this particular area. and this is the main boundary of the area and the satellite image field. So you can easily see that most of this area are like cropland, as you can see here, and you can see some other features like a river, as well as some built-up. So I've described the folder here. So for Sentinel-2, we are using like Sentinel-2 image like from Copernicus, which is like a optical satellite product, and it has like almost 12 bands. Yes, but we are not using like all the bands available. So one thing you need to understand in satellite image is not like the amount of bands. So you need to understand what each band stand for and what is their importance in the particular task that you want to apply the bands to. So for example, we are doing land cover classification. So the type of bands that you're going to use for land cover will be different for the type of band that you're going to use for some task. Let's say you want to perform burnt area analysis or building detection. So you don't use the same band. So you have to understand what each band stands for and how they actually have impacts or how they will influence the features that you want to identify on the image. So if you want to read further what each of these bands stand for, so you can click on this link and see what they are most suitable for. So for this particular purpose, we'll be using like the blue, green, red, the visible parts, the infrared bands, and also the other parts of the infrared, like the longer wavelengths of the infrared. So I've already prepared the data for us because of time so that we can just begin the main task. But in real life projects, it doesn't come like that. So you have to go to the website I listed earlier. Then you get the image, you apply cloud masking because like we saw yesterday, so the atmosphere is not always clear. Sometimes there are clouds in the atmosphere and this cloud can appear on the image and you might need to remove the cloud from the image. Also, the images come in a very large extent, like SWAT width. So you don't want to download the whole image of a large area. So you want to just clip to the extent of your area to save size and also to save download time. So in this particular purpose, like you also need to take notes of this. So when you're doing land cover, so you know land cover changes within some time, especially if you have like cropland and some other feature that can easily change. So sometimes like cropland, as if a cropland has been affected or not cultivated. So at that particular time, it might appear similar to a bare soil or like grassland. So that's why you have to like try to not use a single date image and try to use like maybe a median or mean composite of images across several time periods. So that's why in this particular case, so we we search for all the images available from February to November. Then we now took like you have several images available between this period. So for each pixel in each date, let's assume like we have an image on the 4th of February, then we have the next image after 5 days, that is temporal resolution. On the 6th of February, then we have another image on 11th of February, up to the last date. So we have some other intermediate image. So instead of like using a single image, what we did is that for each pixel across the time frame, so we took the median value. So we now like a sort of kind of aggregation of all these pixels to their median value. So we now get a single image out of all these images. So that was done for each of the bands. So these are like the training sample for this particular classification task. So we are using 5 samples And how do we divide the sample? So actually it depends on several factors, but one of the most important factor is for you, the analyst, to look at the study area on a very high resolution image and see what are the class that you can identify in this particular study area. Also, you can look at existing land cover data product or map and see the kind of classes that you can identify. And also sometimes you might need to go broad depending on the application of your land cover. So you might need to go broader than like this kind of class. For example, you might need to not only consider cropland, but you can also categorize cropland into cultivated or fallow land. So this class, like I mentioned, it depends on several other factors. But to make it simple, to have prepared this like 5 classes for this particular purpose. So I try to describe like what each class represents, so which you can go through later. So this I've explained. So now we begin properly by going to QGIS and perform the task. So the first thing, as you saw in this PDF, I'll be following this particular step. So the first thing now is to add data to QGIS. So there are several ways like you could add data to QGIS, but I think one of the easiest way is maybe to drag the data to QGIS off. But for a start, so I would like recommend to use, so I'll use 2 approaches. So the first one I will use is to go to layer. So you can go to add layer, but this, so let's start from adding the boundary data. So boundary data is a polygon shape file, so which is a vector file in GIS. So you go to add vector layer. So you can see here, like in this left tab, so you are currently on the vector layer. So the software will be expecting you that the file you want to add is actually a vector layer. So here it's telling you to locate the source of your vector data. So you click on this 3 dots here. So you click on this 3 dots to browse the vector data that you want to add. So you come to the data folder. Then you click on boundary. So you click on this last, it might not appear like the kind of icon I have here might not be similar to yours, but you have the same file name. So just look for the one that have .shp. Then you click on open. Then you click on add. So when I add this particular layer, so you're going to see the layer listed here, and it will appear on the map here. So just watch out. So now you can close this, but you can also add the remaining layers. But I'll close it just to show us again the step. So again, to add a layer, there are several ways, but I'm using layer menu. So add layer. So I want to add like a vector layer. So add vector layer. Then I can browse another file that I want to add, or I can also clear this current one that I've loaded here. But you imagine that you want to add data which are not vector, like satellite image, which is a raster format. So you don't want to be going from vector and raster here. So what you can do is to go to your browser. So with this, you can access your whole browser or your file, your desktop, like your browser, and see all the files or folder that you want to access. So in my case, I've already like added this particular folder that we are using for this training as one of my favorite folder. So you can also do that, but if you want to access your browser, so you have your drive, depending on the number of drives you have on your browser, so you can expand them and go to your folder where you save this particular folder that you are using for this training. But in my case, I've added it to my favorite list so that it will appear on top. So I've had all the remaining data from this browser, which is easier compared to going to a specific file format. So the next thing I want to add is the satellite image. So for now, we should add, if you are following along, so you should add the single bands images. So there are 10 single bands image. So to select all of them, just click on the first one. So if you are using like a Windows PC, so hold the shift button in your keyboard, then click on the last band, like band 8A. Then you can now easily drag them to your map or to this layer panel. So all the images have been added to the layer panel. So don't worry for now about organizing these layers. But the next step is to add the train and validation samples, which is also like a vector point file. So you select it, then you drag it here. So that's the data that we need to add for now. So you can also add, you can add the satellite image, like the composites, the S2 median composites, 10 bands, in case we need to use it. Then you can close this data source manager or the browser. Sorry, can you see like the way I'm navigating the files?
Yeah, yes, sir.
Okay, thank you. So I want to confirm like if anyone is following along so that I know if I should go fast or. So if you are following, please let me know in the chat box. Like if you are replicating the step along with me.
There's a thumbs up, like just coming up in their profile.
Okay. So I will proceed. Okay, yeah. So like the way in which the data or the layer appear on the map depends on the order in which they are arranged here. So that's why you see like the training sample is not visible here because the image is on the top of all the layers. So that is the one that is appearing on the map here. So if you uncheck this particular image, you see a square box here. So you can uncheck it. So the next layer will be visible. So, but it's a good practice to organize your file or your data into groups. So how do you do that? So first I will try to move this point data to the top. So now we're moving to organize data into groups. So the second step. So to do that, I'm going to add all these single band images into a single group. So to do that, just click on the first band or single band raster. So the main difference between the file name is like the multi-band image, it has a last service of 10 bands. So that you don't confuse it with these single band images. So for the single band images, we want to put them into a group or what we can call like a container, just to organize them. So you click on the first image. You can hold Shift on your keyboard if you are using Windows PC. Then you click on the last single band image. So to select all the single band image. Then you come to the layers here. So you see like a second icon here, like a very white small icon. So add group. So click on that. So it will put all the layers in a single group. So it will now ask you to give a name to the group. So you can say single band. I prefer to put the group name in uppercase so that I don't get confused with the file or the data name. Single bands. But at the same time, it expands your layer or your data. So you can do that like one after the other, but that will take time. So you can close them by going to this particular icon, the top arrow icon, collapse all. So that will keep them in compact form. So the next thing is to move the boundary to the top because we want to see the boundary or the extent that we want to work on. So I will put the boundary in its own group, just the boundary layer. So you click on the boundary layer. So you go to add group icon. So the similar process that we did for the single band. So you give it a name. I will give it boundary in uppercase. So you can give it any name that you like. So the next one is the training sample. So I'll put it in its own group as well, or I can leave it here. So to just to be on its own at the top. So this composite 10 bands. So I also put it in a group of its own. So you click on it, it comes to add group. Then you can name it composite. So the next step is to set the coordinate system. This is very important. Although depending on the coordinates reference system of your data, so sometimes when you add, or most time when you add your data to QGIS, automatically it will change the coordinate system of your project file to the coordinate system of the layer. So you can check this particular boundary, which is the first data that we added to the map. So you can check the properties and check the coordinate system. So you can right click on the layer if you want to check the properties. Then you see properties from the option, like the last option. So it will tell you like the parts of the file on your browser and some other information that you need to know, like the type of geometry, polygon, shapefile, and also like the coordinate reference system of this particular file. So we are using like a projected coordinate system for Nigeria. So the next thing is to change how our layers appear. So we want to change the symbology. So currently now this study area is like preventing us from seeing what is on the image because it has a field color. So the first thing to do is to change the color so that it only have outline color, but it doesn't have the field color because we want to see what is inside the boundary. So to change the symbology, just click on the layer. So in this case, the boundary layer, the shapefile, ADGR, FAO. So then right click on it. So you see, you go to properties. So this time around, we are not changing the, we are not checking the information about data. So we want to change the symbology. So you come to symbology. So by default, it's going to have like a random field color, but we don't want it to have like a field color. So you come to simple field here. So this is the current color that it has, like the field color. So you change it to transparent field. So for the outline color, like the stroke color, so you can change that to any color that you like, but I'll keep it as a black. So you can increase the thickness of the outline just by 1 up. Then you can apply to see the changes. So if you are okay, you click on OK. So the next step is to change the symbology of this training and validation sample because they are not the same. So they have unique attributes that you can use to distinguish them. This represents several classes, but currently now we are seeing them in the same color, but they contain several classes like bare soil, built up, water. So we want to see which one of them is water, which one of them is built up. So you can replace a similar process that we did now. So you right click on it. So you go to properties. So to do it on your own, so you can come to, instead of single symbol, you don't want to use a single symbol. So you want to use categorize, you want to categorize them based on the land cover class. So it will ask you which of the value or attributes that you want to use to categorize them. So this particular shapefile has some attributes, which I'm going to show you later. So in the value feed, so you select one of the attributes that are present in this data. So you can use a class. Then you can now classify. So automatically, it will check all the available unique value in this particular attributes of this data. So you now categorize all of them into this class. So you can uncheck this other value. Then you apply. But this color doesn't match the color I showed in the PDF. So this kind of color. So that is where that's the purpose of me creating some layer so that you can also apply the same symbology and we have a similar look. So instead of doing the symbology yourself, so you can come to style at the bottom part of this interface. Then you can load an existing QGIS style. So you load style. So this interface will happen, will pop up. Then you have to select the style file, which is part of the folder that has been shared with you. So if you go to the folder shared with you, so the data, sorry, the hands-on folder. So there's a folder called QML layer style. So you can double click on that. So this is the style or symbology file for the land cover class. So you click on it, then open. So you can load the style. So you see automatically, so it has changed. The preview has changed to what we have in the PDF. So if I apply this style now, you will see it will change to what we have here. So that's the importance of like having like a symbology file. So because it also enables us to reproduce what I've done and have similar results. So next, for this single band image. They are like black and white, so there is no need for us to change their symbology. So let's see what we have. So I will try to arrange them like in ascending order. So it's a good idea to save your work as you are progressing. So let me also do that. So like you have to know like what each band stand for from the satellite's provider detail. So I've already shown us like this. So like the band 2 is the blue band, band 3 is the green, and band 4 is the red band. So with that information, you can use it to examine how does each of these how does the future look like in each of these band. So this is a water body. So the blue color is water. Let me expand. So you can expand the training layer so that you see the classes that you have under it. So the blue color like is the built up, and you can see like it's very dark compared to built up that are bright in color for the band 2. So you can also check the properties in band 3. And you see like maybe the water became a bit bright here in the green band. So you can check even the color of the water in a RGB image and see why does it appear like a bit bright in the green compared to the blue, which like is kind of different from what we know about the properties of water. So, and that's where you need a base map. So you can go, remember at the beginning of the class, we install the quick map services. So we want to add a base map so that we see even in context, where are we in the world or in the globe? What is in our surroundings? So you come to web. So after you must have installed the plugin. So you come to quick map services. Then you come to, let's start with Google because we want to see a satellite view of the world. So go to Google, then select Google Satellites. So this will add like a satellite-based map. You can also add more than one base map. Let's also add the OpenStreetMap based map. So you go to web again, quick map services, OSM, OSM standard. So now we have two different base map. But like I mentioned earlier, the layer at the top is the one that will be displayed on the map. So if I uncheck this one, so you're going to see like the OSM base map. So we can also put these two base map in a unique group. So you select both of the base map, you come to add group, then you give it a name, base map, for example. So let's see what the water I showed earlier. So why does the reflectance in the green appear to be higher than in the blue? So you can see there are some kind of grasses or green feature inside the water. It's not really like a pure water. So that's why it appears like the reflectance was higher in the green band, like it appears brighter in the green band, like band 3, compared to the blue band. So that's one of the things that we talked about yesterday. And we're also going to explore the value of this pixel. Like we compare the value in the blue band compared to the value in the green band. So we're going to do that here. So the next step now is to combine. So let me follow. So we have had the base map. So I will switch these two steps. I'll come back to this one. So let's perform this. So I will uncheck the land cover classes for now. We want to work on the satellite images. So maybe you can change the boundary to outline to a red color so that we can see the boundary different from the single band images. So again, you right click on that, you go to properties. So you click on simple fill. So the stroke color, which is the outline color, you change it from black to red. Apply, okay. Yeah, so now we can see our boundary very clearly. But we have these images in single bands, but we want them to be a single image that comprise of many bands, like all these bands together in a single image. So how do we do that? So you go to raster, you go to miscellaneous, then you select the first option, build virtual raster. So this interface will open. Sorry. Then it will ask you to select like the input raster files that you want to combine or you want to perform operation on. So you're going to select, you click on in the input layers, you click on these three dots, then it will list the raster layer that you have here. So you can see it only lists the raster layer. You can see the boundary of ADGIA or the train file sample because this is a vector file. So you select all the single band one after the other. So don't make mistake, band 11, band 12. So here it's recommended to arrange the bands in the order that you're going to remember. Because the purpose is that once we combine them in a single raster file, so they are going to be listed as an like kind of attributes, not really attribute, but just to make it simple for us to comprehend. So they are going to be listed as a kind of like attributes, and they might not have like this kind of name. But for us to remember how they will appear in the combined image, so it's advisable to arrange them in a serial order. So I will try to arrange them so that they have a serial order. So band 2, band 3, band 4. So band 2, 3, 4, 5, 6, 7, 8, 8, 11, 12. So it's very important to take note of the order of this band here. 3, 4, 5, 6, 7, 8, 8, 11, 12. Yeah. So you select all the files that you want to combine. So I've selected all the single band images. Then you click on OK. So you see like I selected 10 inputs. And we're going to have an image as the output is going to be an image with 10 different bands. So it will ask you, do you want to place each input file as a separate band? So it's asking, do you want the output to be a multi-band raster file? So you click on OK. So I don't want to save this because we don't actually need it for this purpose, but I just want to show us like how it looks like. But if you want to save it, so you can click on this drop down, then you click on save to file. So let's actually save it just to show. So there's a folder, there's an empty folder, composite or comp_band. So you can save it there. So give it a name such as, let's say, I'll just say composite, not to make it look similar to what I already have here. So let's say composite. So I'll say composite, yeah. Then you click on save. So you ensure like everything is okay. You set the number of bands. You place each input file into a separate band. Then you click on run. So you can see it's generate like a colored image for you. So it has combined all these single bands into a single image that contains multiple bands. So you can change the way the color appear. So you click on properties. So like I mentioned yesterday, the computer has 3 channels, the red, green, and blue. So here now, you can see we have band 01, 02, 03. So you don't have the same name that you have here, like B2, B3, B4. So that's the importance of what I showed earlier, that you should arrange the band in serial so that you can remember what they stand for. So you can play around the band combination. There are several information online on which kind of band combination are useful for some kind of purpose. But let's say, for example, we want to see the vegetation in red color. So we know that the infrared band reflects a lot of vegetation. So you can set the red band to, let's say, 8. So 8 is 8A. So this is the 8th band. Then you can set the green band to green. So green should be 02 because we have 01, which is band 2. This is now 02. So the red, you can set this one to, no, let's set this green band to red band of the image. So that will be, this is 01 now, this is 02, and this is 03. So let's set this 02. Sorry, 03. So this is infrared red. So we want to set this to green. So green is the band 3, which is now 01, 02. So you can apply, if you apply this, you can see the vegetation now appear like in red color because we put the infrared in the red channel of the computer, and the vegetation has most reflectance in the infrared. So that's why it appears red. So, but that's not the main thing we want to do today. So you will see like the extent of the image is more than our boundary. It doesn't follow the actual contour or the outline of our boundary. So the next step we want to perform is to clip this image to match the perfect extent of our boundary. So to do that, you go to raster again in the menu bar. So this time around, you go to extraction. So you see extract or clip raster by mask layer. So by default, it will take the raster layer that you currently select here. So it will ask you what is the outline that you want to use to clip the raster. So that's the mask layer. So we want to use our boundary, ADGR. Then you can keep the pixel size of your input raster, like the spatial resolution. Then you have to save this. So there is a place clipped parenthesis mask. So you select the drop down, then you save to file. So in the same comp band, so you can save it as a composite clipped. So this time around, save it as a GeoTIFF file. You see TIFF. So save it like as a TIFF file, not just like a virtual raster. So you go to the save as type, you select like the TIFF file, then you save it. So you set like the image you want to clip, the outline or the vector file that you want to define the extent of clipping. Then you keep the resolution of the input image. Then you select or you define the output part. You can now run it. So it has finished. So you can uncheck the previous one. So this is a new composite image that has been clipped to the outline, but now you can see some black background color. So these are what they call no data pixel. So we're going to remove that now so that you can clearly see the image without any outer black color. So again, you right click on the clip image, you go to properties, then you come to transparency, because these are like pixels with no value. So you define the no data value as 0. So you click on apply. So you can see that the black display outside the boundary has now disappeared. So you can now move this composite to the composite group. So you can uncheck the single band raster files or layers, and that's the purpose of like grouping. That's one of the purpose of grouping your layers. So to uncheck all these layers, you can just uncheck this group. So now we'll be working on the composite clip for the remaining parts of this analysis or land cover classification. So again, you are free to choose like or to change the band, how the image appear by just going to properties and symbology. So you can change the band combination, but let's keep it like this. So the next step is to check the attributes of our training sample. So these are the sample. So you want to see what does this point, what do they contain? So you right click on the sample, on the file or the layer. Then you click on open attribute table. So this is what is inside this particular layer of file. So if you want this to stay in a stable place, so you can click on this last small icon to dock the attribute table, similar to what you have in ArcGIS Pro. So it will place it like in a very stable place here. So these are the unique classes that you have, and this is what they represent, like similar to what I've shown here. So class 1 is a bare soil, class 2 is built up, class 3 is cropland, class 4 is tree, and class 5 is water. So you can select one of these files and see where it is on the map. So you can click from the row. So this has been selected, but you don't know where it is. So you can use like the zoom. There's an icon here that it will zoom the map to the current data or points that you selected on the attributes. So this particular point that you selected now, like the bare soil. So let's go to another point and see. Let's say bit of, for example. So you can zoom it. And this is the importance of like resolution. So now you are not sure if this is actually bit up, because the resolution of the image is a bit low. And this takes us to how did we get this sample? So because it's not easy to identify individual feature from this kind of image resolution. So although you can see maybe the cropland clearly, but you can't see individual building, for example, very clearly. So that's where you need like a very high resolution image to create your sample in most cases. So what you do is that, let me turn off the composite image. So what you do is that you use images such as like Google high resolution or other available high resolution images. Then you zoom into areas like this. Then you use like the shapefile tool and create samples. Like you click on this point, then you label the point. So that's not the the main focus of this workshop or webinar, but just to let us know like how these are being collected. So if you check this point against the base map, so you can see this one sample here, which is built up. So you look around. So this is another sample. But you have to take notes here of the date of your base map and the date of your satellite image that you want to use to classify, so that they have like similar kind of information. So you can read further like about all these points. So let's go back to our composite image and our training sample. So let's try to explore the reflectance value, for example, of this particular water or like a wetland. So like we have several bands present in this particular composite clip. We have up to 10 bands. We want to see what is the reflectance value of this point in each of these bands. So to do that, just just select the identify feature tool in the toolbar. So this particular tool that has like an eye and a mouse pointer. So select the tool. Ensure that you select the image that has the bands or the bands combined. Then you click on the point here. So these are the reflectance value, which have been sort of normalized. So yesterday we saw values in 1000 range, but this has been divided by 1000. So you can see the value. Remember, this is blue, green, red, and the remaining one are the infrared bands in several wavelengths. It's in several wavelengths or several range of infrared. So band 1 is blue band. So the reflectance value is lower than that of the green. And that's why we saw that when we check the individual band, so you can see the water or wetland here, it appears brighter than how it appears in the blue. So you can repeat the process for several other features there and check how does their reflectance value looks like across all the bands. So now we are moving forward and we are getting closer to the main task. So we have done this just now. So we have all these samples on the image, like we have it here, but we need to divide them into what they call training and validation sample. So we want to use some parts of the sample to train the model and use the other part to evaluate the model or to improve the model. So if you check the number of sample, like all these point sample, there are about 1,450 points, which you can see here, like you can see the total features. So the ratio to divide the point is not like uniform. There are several ratio that you can use, maybe 80% for training, 20 for validation. It depends on the task and some other factor. But for this purpose, I've chose to use 70 to train the model and the remaining 30% to evaluate the model. So you can do this like manually by just using like random sampling. But for this purpose, we are going to use the OVO toolbox to do the splitting for us in a random way, so that anybody can also like do the same step and get similar results to our results. So also to enable you understand like what the process we want to perform looks like. So because now we are going to be moving to the overview toolbox, and we'll be doing some clicking, inputting parameter, and getting the results. But it's always good to understand what is going on behind the software process. So we have this sample. So we are going to tell the software, divide this sample into training, 70% of the sample, take it to train, take the remaining 30% to evaluate your performance. Then both samples will now be used to extract the reflectance value of each band, and they will be saved in each of the points. So what we saw here now, all these values that we saw for this single point that we check on this image. So the model will check the reflectance value of all the bands for all the points, and it will now learn the pattern of the points, like how does each point behave across all the bands or features. Then these points will have updated information. So apart from the class that they have currently, so they have like this class attribute and the label, although the label is not really important. It's just for us human being to know what each numerical value or integer, what they stand for. So apart from this class attributes, so these points will now have more information about what is their reflectance value in band 2, band 3, and all the other bands. So this is what the model will now use, that if a class is 4 and it behaves in this manner across the bands, that means it's this particular class. So when it sees another unknown point, because we don't have all points labeled on the image, so when it sees another pixel that have similar pattern of band reflectance, so it will look at which of this class does it resemble. So that's the purpose of like training the model with sample. So there are several ways or several models that we could use, and we can check what is how does each model, how can we interpret each model? What kind of approach do they use to select sample or to perform classification? So here we have a model that, like I mentioned, there are a lot of models. We have random forest and some other machine learning model. But for this purpose, we are going to use random forest because it has been used in a lot of paper and work and has been shown to perform very well for land cover classification. So the model will now use these features to learn and now use that to classify all the pixels in the image. So that's what we are going to now. So now it's time to go to OTB and input our parameters and data. So I will close this, identify results. So you go to processing toolbox. So you go to OTB. So you go to learning. So you select train images classifier. So double click that. So to open this interface for you to input all your parameters. And one good thing is that like if you are not sure what each of these parameters stand for, so you can click on help. So this will open so it will open the interface for you to read the documentation and see what each of them stand for. So you can do that later and explore the documentation of these two. So the first thing is like the image that I want to use. So you select the image here. So don't make a mistake here. So you are using the composite clipped. Okay. So the next thing is the vector list that contains all the samples that I want to use. So you could see like this is like optional. If you have divided the sample by yourself, like if you have performed this process already and you have this training sample separate shapefile, the testing or validation sample as a separate shapefile. So you can select the validation vector sample in this place. But in our case, we have both all the samples as a single file. So we want the OTB to help us divide it into training and sample, and we're going to specify what kind of ratio should it use. So just ignore like the remaining parts here up to this point. So here you have to specify the ratio like I showed earlier, and the ratio here is the percentage that it will use for the training sample. So we want 30% to be for the training sample. So you select or you enter 0.3, which is 30%. So it will ask you for the feed or the column that contain the integer value for all the land cover label or class. So like I showed here, so the class column or feed contain the unique name of the land cover. So you select class. So if you have some additional information like the digital elevation model, so you can explore that, but we don't have that for this particular purpose. So the classifier that you want to use for the training. So there are several models that you can use or algorithm, but like I mentioned, we are going to use random forest machine learning algorithm. So this RF is random forest. So you have some other like support vector machine and the like. So there are several parameters that you can change in the random forest. So you can check whether what each of these parameter, what they stand for, and how you can change them to improve your results. But for this particular purpose, we leave it as default, but later you can explore and see how changing the parameter can improve your results. But this random seed is very important. So that like when you run this again, so for example, the OTB here is going to split our data for us into training and validation. So if you don't put a random seed number here, each time you run it again, you will end up with having different points going to training and different set of points going to validation. But if you put a random seed, so it will ensure anytime you run it, the same set of points are being in the training and the same set of points will also be in the validation set. So I'll use like 42 is a common number that is being used for random seed. So let's put 42. So what the output of this process will be is like a model that has learned to identify land cover classes based on the image reflectance and the sample that we give to it. So you save the output model. So you click on this drop down. So you click on save to file. And you go to the folder. You have output folder. So there's a folder called model. So now you give it a name that you want. Let's say Adegia LC model. So it's very important to use, no, let's say RF model. So because we use random forest RF model. So it's very important to give it a file extension dot model. So you save it. So you have defined the path which the trained model will be saved into. So the next thing is to save the confusion matrix or the error matrix that you use to evaluate or see how your model perform. So you save to file. So there's another output folder called confusion matrix. So I already put this calculator here, which we are going to see later if time permits us. So you again added here LC confusion. So here, this is like a text file. You can save it like a CSV file or .txt file. So you can either save it as .csv or .txt. So I prefer to use .csv. So just to go over it again, we input the image, the composite that has been clipped to the boundary. So we input our training and validation sample. So we instruct the tool to split the sample to training 70% and the remaining part 30% to validate performance. Then we instruct the tool that the classes that we have in our sample are contained in this particular attribute or color. Then we are using random forest, which you can change the upper parameters later. But for now, we kept it as default. So we put random seed to ensure that we can reproduce this kind of results anytime and by any other person. So you can run the process now. So depending on the capacity of your laptop, it shouldn't take like much time. So here you can print, or you should even print this log file because it contains all information about your model, the performance, the accuracy metric, and the like, which we are going to explore at the final part. But for now, you have to save it here. Save log to file. So you can save this as a text file, confusion, like you can just add Adigia so that you know where it belongs to. Adigia LC random forest RF confusion matrix .txt. So later we'll come back to this. But just you can even view the result from here. Like so first thing is that it gives you summary of what you input. So the input parameters, in case you forgot what you actually input to the model. So it will tell you input this image, you input this sample. So it will tell you the full path. So what are the parameters that you enter? So it will tell you all those information. And that's the purpose, or one of the purpose that we save this log file. You can go back to it anytime and see what did I actually did. So this confusion matrix is very important. So it tell you like how does the model perform in terms of accuracy. So you can copy this later and properly format it to a confusion matrix. And these are some kind of like accuracy metric that you can use to evaluate your land cover classification accuracy. So this is per class accuracy for each of the class. How do they perform compared to all the class? And also how did the model try to perform in terms of distinguishing class 1 from all other classes. So you can do that, evaluate the accuracy of all the classes and also the kappa index. So later you can explore all this kind of accuracy because of time. So you can close this. Now we have a model file which has been trained. So you come to output. So we have this model file which have been trained on how to identify land cover class using image of Adegia local government. So we want to use this image now to classify the whole, we want to use this model now to classify the whole image into the 5 land cover classes that we have. So you go back to QGIS. So this time around, we go to classify, no, in OTB, also in learning, you go to image classifier. So you double click on it. So which image do you want to classify? So you use the same image that we used earlier, composite clipped, that we used to train the model. Then it will ask you to input the model file, the model that you have trained. So you select the model file, output. So we'll save the model here, open. So it will ask you number of classes that you have in the model. Because we know it, we can save 5 classes, but at the same time, you can choose to just leave it empty. So it will see from the model the number of classes that are available. So you have to save the land cover map or raster layer. So here, you select the drop down, save to file. Then you go to output folder. So there's one empty folder, classify LC layer. So open that folder. So give it a name, Adogia land cover, random forest, default, because we didn't change anything in the parameter. So you can give it any name that you like, but just for us to remember what kind of approach we apply. So the next thing is the confidence map. So our confidence is the model. So you can also save that, but this is like optional, it's not really compulsory. So you can save to file. So similar name, Adegia LC RF default. So you give it confidence so that you know this is not the main map or main land cover layer, confidence. So the last one, you can skip this one, like the probability map. So skip output. So this is like a very straightforward process. You input the image, the model that you have trained, then you select the output folder or path, then you can run it. So let me drag it there. So you have your land cover layer. So, oh, sorry. Okay. So this is the confidence layer, which we don't actually need for now, but let's drop it down. So this is the land cover layer, and you can see it has 5 classes, like 1 to 5, but you can see it has like some output pixel. What you need to do away with those pixels is to clip the land cover layer to the extent of our boundary, like we did for the image. So you go to raster, extraction, clip raster by mask layer. Then you want to clip it to our boundary, ADGR. So you can keep the resolution of the original raster layer. Then you define the path that you want to save it to. So we save it to the same place, but we add another word to know like this is the clip version of our clipped. So I'll bring all this land cover and put them in a different group. Classified. Let's see. So this is the land cover that we have clipped to the extent of our analysis. So I will now proceed to check the properties. So although we have, so you can classify to see the number of unique class that you have. So instead of using like a single band, you can use unique values. So we now tell the QGIS to classify based on the unique value present in this particular layer. So the 0 are the output pixel with no value. So you can apply and see. So each of these color represent the class that we defined earlier. So we remove this 0 class, the outside pixel. Just click on it and click on the minus button here. So you can apply again. So this is the land cover map. But this color doesn't represent the color that we have, for example, in our sample here. So that's the purpose of preparing like a kind of symbology that you can easily apply. Then you have the same appearance like mine. So go to style, you have to load a style. So this land cover raster style, open, apply, okay. So the land cover now appear like based on the color that we have here and the color I showed in the PDF. So you can see, you can compare the results by just visually comparing it maybe with the base map or with satellite image. Let's use the base map, for example. So there is one plugin, transparency plugin. So you can install that later, but I've already done that. So I'll use that to try and see. Also, you can check and uncheck to see. But remember, we use the default parameters for the random forest, so the result might not be the best, but you can later improve several other things, which I'm going to talk about later. But because of time, let's go to make the map. But I'm going to make some general points that we need to take note. So to make this to a map, so you go to project, you go to new print layout. So you give it a name, like what name do you want to call this print layout, where you are going to make your final map. Just like you have layouts in ArcGIS Pro. Let's say Aditya run cover RF default. Okay. So a print layout will open as a new window. So it's better or more convenient if you have a second monitor. So what you need to do here is to add this map from the map interface to the layout. So it's better or recommended to ensure that your map fits the current display here, so that when you add it to the layout, it will also appear to fit the page. So you come to, in the layout view, not the main map view, you come to add item, add map. Then you can draw it. So it will show what you have on the map. So if you should uncheck this land cover layer on the map and you go back to your layout, it will also disappear on the map. So you can see, but to prevent that from happening, so after you have, let me check it again. So after you have properly placed your map, you have set the scale. So let's change the scale to, let's say, 45,000. 45. So you can move the map item or the main map within the frame by using this particular tool, move item in content. So to move what is inside the map frame. But be careful, if you should click or adjust the scroll of your mouse, it will increase the scale or decrease the scale, depending on whether you push the scroll forward or backward. So always remember to change the tool back to this select or move item. So you can change the base map before you complete the task. Maybe you can use a very light base map like OSM base map. So you just feel free to adjust as you like. Because of time, I'll just add some basic map elements. So the next thing you can add the title, add item, add label. So maybe you want to add land cover of Adejia, Nigeria. So you can change the font of this title. Let's say bold. You can increase the size. Let me enlarge this one. So you can increase the size to, let's say, 20. Yeah. So you can place the title anywhere you like. So I will try to adjust this map. So when you are doing it on your own, you have much time to make it like better. But because of time, I'm just trying to make it fast. So next, you can also add the scale bar. Oh, the legend is very important. Sorry, it's most important than because nobody knows what this color stands for. So add item, you add legend. So you can draw it anywhere. So by default, it's going to pick all the layers that you have in the main map and add them to the legend. So, but you don't need all of them. So you only need this. So you have to uncheck auto update. Then you'll be able to remove the one that you don't need. So what I will do is to just select the one I need, like this Adejia land cover. So I will bring it up to the top, so you can see. Then I can also select the boundary, bring it to the top. Then I can now select the remaining one and remove them from the legend. So select the first one you want to remove and select the last one by holding Shift on your keyboard. So you can use the minus icon, this red minus icon, to remove the remaining ones. So you can move the legend here. So you can see the legend has the name of the layer. So you can change that. So let's start with the land cover layer. So you don't want this band one to show because it adds no meaning to the map. So you can click on that, remove it with the minus icon here. So this, you want to change the name from the layer name to, let's say, land cover. So Adejia, you want to change it to maybe just Adejia alone. Then you want to change this to represent the meaningful classes that we have. Sorry. So to represent these classes, so you can just copy from here, sorry. So you double click on each of this color. So you'll be able to change the name bit top. So you do similar thing for the other classes. Cropland. So you can change the, like, for example, the font size, because this land cover should appear like the title land cover or subtitle should appear maybe bold or different from the remaining one. So you can click on the fonts and text formatting. So I think this should be maybe title font. So title font, you can change it to bold. Sorry, it's not title font. Maybe let's see if it's subgroup font. Yeah. So this line cover belongs to subgroup fonts. So you can change it to bold. You can increase the font size. Even the single class, you can change the font here if you want to increase the font size. So on your home, you can explore further and try to make it better. So I'm not sure if a scale is important, but you can also add a scale bar. So you can adjust the scale bar if you need to do the. So here you can change the multiplier, the units, maybe you want meters, or so you can also add a not arrow at that time. Not arrow. So you can move it to the map. You can change the type or the color of the not arrow. So if you want to change the type of the arrow, you can search for another one here. Just type not, sorry. So there are several type of not arrow that you can change. So you can change the color. Maybe you don't want the field color to be white. You can change it to black. Then you can give the map a frame. So you click on the map. So you scroll down here. So you give it a frame. You can increase the thickness of the frame. So you just make it like looks better than this, but because of time, so I will keep it this way. But just to mention, like all this, as you are adding all these items, so they are being listed in this place. So for the map that you added, so it's called map 1. So this particular map frame. So I mentioned something earlier that if you change what you are currently displaying on this main map, it will also change on the layout. So let me repeat that again. So I've unchecked the land cover. So let's go back to the layout. So you can see it also disappear. But how do you prevent that from happening? So you have to, let me check it again. So it will also come up here again. So to prevent that from happening, so you have to lock the layers and also lock style for the layers. So if you should go back here and uncheck the land cover or even uncheck the base map. So let's go back. So it will still remain the same here. So another thing that you need to note, like you can go and interpret the log file. Maybe later, if you have much time, you can look over to this. So this log file, so you can go through it and see like what is the performance of each of the class and what is the kappa index, although there are some kind of debates or comments on the kappa index, although, but this is not for this class. But just go through over them and see like what is the performance and try to know what each of these stand for. I try to put a note here to explain, but you can go further and like try to explore them and see what they actually stand for. But let's see how we can arrange it in a proper tabular format. So I put this metric calculator, which is like a spreadsheet that you can just copy the row and columns from OVO toolbox and paste it here. Then it will compute the user accuracy, the same kind of result you saw there in OTB. It will also compute it for you here in a way that you can copy it and put in your work in a tabular format. So let's copy the result that we got from OTB. So we got this result from OTB. So you can copy the main. So these are the classes. Okay, so these are the classes like class 1, 2, 3, 4, 5. So in row and column. So you just copy the main numbers here. Copy. Then you paste them. Because I have similar number of classes here, I designed this particularly for this number of class, like 1, 2, 3, 4, 5. So if you have more than 5 classes, you need to adjust this kind of table. So you then come and paste. So if you compare like what you have here to what we got from the OTB, for example, the class 1, so the recall of class 1, which is similar or the same with user accuracy, is 0.75, which is 75%. So if you check for class 2, is 0.89, which is 89.2%. So you can copy this to a Microsoft Word document and give it a better presentation. So let me see if I've covered everything I listed here. Yeah, so this will be like where I will stop in the practical aspect, but just to make some notes on what we should consider if we are doing actual task. So it's the sampling techniques. So how do I divide the sample? So where do I put the sample on the map? So you could see like, should I just put all the built up in just one part or one corner of the map, even when they are built up in other areas? Can I just pick my small sample in just one part of the map? So these are things that you also need to consider. So you could also see here, so these are the distribution of the sample. So from the map, you could see that cropland has or dominates the study area. So we expect to have more classes of cropland, and that's why you have many yellow points. But that's also try to introduce some kind of bias into the model, because it has learned so much about cropland compared to, let's say, this small class. This class 4, it has only 6% of the data, whereas cropland has more than 40% of the sample. So you have to also take notes of this kind of challenge or problem. So like I mentioned, so we use the default parameter, but you can go further and see what each of these parameters, what they stand for, and how you can adjust those parameters. Also, what I showed you now, the confusion matrix is not, to me, is not the best or the final stop. So I would advise, after you perform this kind of training and you put the model divided for you, training and validation, then you get the performance. So you should go on and get some random extra points and use it to further evaluate your model. So there's a way to do that, but because of time, so we couldn't cover that in this part. So that's all from me for this today's class. If you have any questions, so I'm happy to attend to them.
Thank you so much, Lukman, for this wonderful section. Please, guys, let's give him a virtual round of applause. So if you have any question, just put up your hands, via the emoji on your profile, and I'll call you to ask your question, and Lukman would be happy to respond. Okay, Chidemenike, I see you. You can unmute yourself and ask your question, please.
Sorry, I just wanted to ask if the recording will be shared with participants.
Yeah, so there is a link after the class. I'll paste the link where you click on the link and then you insert your email address if you are interested in the recording. And then we'll send it to you once we have the recording. Okay, Jessica, you can
Thank you.
unmute yourself, please, and ask your question.
Hi there. Thank you very much for the very interesting workshop. I'm currently on a Mac, and I've found that it is very difficult to download the Orfeo toolbox onto a Mac, and that you have to use a Docker image and go through a whole lot of different processes. So I was wondering if there's any other similar plugin that you can use on a Mac, or if this is quite an original plugin that isn't similar to any others.
Yeah. So to my understanding or from my experience, so there are other plugins that you could use for land cover classification in QGIS. But I think there has been like maybe, although I don't use Mac, but I've seen like people make similar concern or complain about having issue to install some plugin and the like. But to address your question, like there is one plugin which is very popular, CSP plugin, semi-automatic classification plugin, which you can also try. But I believe the OTB should also like you should be able to find a way out on how to go about it on Mac. So I'm going to look into that and see if we find a solution so it will be communicated on the African in Environmental Science platform.
Cool, thanks very much. Appreciate it.
Yeah, I can.
If you have any questions, just put up your hands and I'll call you, please.
Mm.
Okay, thank you very much, my dear teacher, Mukima and Lita. I want to send the video session. Are you sending for us the session video or slides?
Mohammed, we can't hear you clearly. Please, can you speak audible? Like we can't hear you. Your voice is a bit low.
I think it's asking for the like recording of the session.
Oh, okay. Yeah, I just pasted the link now. If you click on the link, put your email address. Once we have the recording, because it's recording via cloud, we'll send it to you. To anyone that put their email address that is interested in the recording. But the link is there now. Just click on the link and put your email address in the response. So for those that are interested in the recording, the link is there, please. Just click on the link and insert your email address. Okay, so if there's no further question, if you have any question, just unmute yourself, please. Okay, if there's no question, this will be the end of the class. Thank you so much, everyone. Don't forget to follow the African Women in GIS platform.
Now in Hamilton, it's 2 degrees and mostly sunny. Today, it'll be cloudy, with a forecast high of 7 and a low of 2.
Bye, everyone. That would be all, and see you guys. Don't forget to follow the African Women in Africans in Environmental Science on LinkedIn and on Twitter. And if there's any updates you see there, thank you so much, Lukman.